We use functions all the time in mathematics, so in this video we're going to learn how to define functions in Python. Let's begin by defining the function which sends a number x to x squared. I'm going to talk you through how the Python definition works step by step. When you begin a Python function definition, you have to use the word def, D-E-F, which is short for define or definition. After def, you put the name of your function, which can be any Python variable name. I'll call this function square. Following the function name, you have to put in brackets variable names to represent any inputs to the function. Our function only has one input, and I'm going to call it x. Finally, the first line of the function definition has to end with a colon like this. Once you've finished the first line, you have to write the Python code which is going to compute the output of your function. All of the code which is part of the function definition has to be indented by 4 spaces. That means it has to have 4 spaces to the left of each line, like this. Once you finish computing the output, you tell Python what the output of your function is going to be using the word return. So here we just have return and then x squared because the output of our function should be x squared when the input is x. If we run the function definition, we can then start to evaluate that function. So for example, if we want to evaluate our function with the input -2, we can just use the ordinary mathematical notation square brackets -2 brackets. When you run this, you see we get 4 as expected. On the other hand, if we want the square of 4, we just change -2 to 4, run it again, and you can see we get 16. Evaluating a function with a particular input is called calling that function. In the last couple of videos, we worked with a quadratic, namely 2x squared plus 5x plus 2. In the code cell here, which I copied from the previous video, we created variables to represent the 2 roots of that quadratic. They're root underscore plus and root underscore minus. I'm going to run that cell so that those variables are defined. What I'm now going to do is write a function which will compute the values of that quadratic. So again, let's go through it step by step. We begin our function definition with the word def. Then we have the name of the function. I'm going to call this function f. Then in brackets, I need to put any inputs. I need to put variable names to represent any inputs to my function. Our function just has a single input, and I'm going to call that input y, just to show you that the input can be any Python variable name. Finally, we have to end the first line with a colon, and then any subsequent lines which are part of the definition have to be indented by 4 spaces. When I press enter here, the JupyTer Notebook will automatically add those 4 spaces for me. What we now have to do is specify what the output of the function is when its input is y. We do that with the return keyword, and then we need 2 times y squared plus 5 times y plus 2. That's it. We've now finished defining our function, and when we run that code cell, we'll then be able to use f to compute values of that quadratic. Let's check that f of root plus is 0. You can see it is, and similarly for f of root minus. So it looks like things are working. Hopefully this starts to show you why defining functions in Python is such a good idea. One reason is simply that it saves you a lot of typing, because instead of having to type out 2 times root plus squared plus 5 times root plus 2, I just had to do f of root plus. So if we're interested in evaluating that quadratic at a lot of different inputs, having a function which computes the values saves us a lot of typing. The functions we've seen so far only had 1 input each, but Python functions can have as many inputs as you like. Indeed, they can have 0 inputs. To define a 2-input function, all you do is separate the names for your inputs with commas. So here we're going to define a function called add, which has 2 inputs and returns the sum of its 2 inputs. As usual, we begin with the keyword def, then the function name, which is just add, and then in brackets, because we want 2 inputs to our function, we're going to call one of them a, and then we have a comma, and then we have the name for the other input, which is going to be b. Finally, we have to finish with a colon. And then on the next line, we use the word return to tell Python what the output's going to be, and that output is going to be a plus b. So once we've run this, we can then actually call the function. So I'm going to call it with inputs -1 and 1, and you can see the output is 0 as expected. One useful function which is predefined, so defined for you in Python, is called print. And what print does is display something on the screen. So here's an example of calling the Python print function. The input here is the word hello in quotes. That's a special type of Python object called a string, which we're going to discuss later. And what print does is just displays its input on the screen. So you can see that it has printed out the word hello. You can also call the print function with numbers as an input. So here print 1.234 is going to display 1.234. Print can even take more than one argument. If you want to print two different things, for example 1.2.34 and 3, then you can just put the arguments, put the things you want to print inside the call to the print function separated by a comma. So when I do this, you can see it'll print out both of those things. You can even mix different types of things to the screen, and this is helpful when you want to print a useful message. So for example, we might print 1, and then the word plus, and then the number 2, and then the word is, and then the number 3. And when I print this, you'll see it shows 1 plus 2 is 3. This can be helpful when you want to print something out which actually explains something that's happening in a computation. There's an important thing about printing to the screen which beginners are often confused by when they first learn about printing and about Python functions. Printing is different to returning a value. You can use a returned value from a function in a computation, for example. If you had a function which returned a number, then let's say your function was called f, then f of x plus 1 would be a legitimate Python expression. But when a value is printed on the screen, that's it. It's just displayed on the screen. It's not available for use in computations. To show you the difference, let's consider two functions called f and g, which I'm going to define in this code cell. The function f takes a single input x, and what it does is print x plus 1 on the screen. It doesn't have any return value. F does not return a value at all. The function g again has a single input, which we've referred to using the variable x, and what it does is return the value x plus 1. So g does have an output. It has the output which is 1 bigger than its input. Let's run that code cell so that those two functions are now defined and look at what f of 1 is. So what f does is add 1 to its argument and then display that on the screen. You can see that when I called f, it's printed the value 2 on the screen. Now let's call g of 1. You can see that g of 1 has displayed the value 2, and you can also see that there's a very subtle difference between the results of those two functions. When we called g, we got the word out next to the output, and that is the Jupyter Notebook's way of telling you that this 2 was actually returned as a value from the function g. It wasn't just printed to the screen, it was returned as a value, so we could have used it in a future computation. For example, if we wanted to do g of 1 plus 1, well, g of 1 would return 2, so this will be the same as 2 plus 1, so when I run this code cell, I'll get the value 3. On the other hand, what's going to happen when I run f of 1 plus 1? Well, f of 1 does not return anything. It's going to print 2 on the screen, but f of 1 is not a thing, so it does not return a value. When you try to add the number 1 to a non-existent value, you're going to get an error. So you can see when I try and do this, Python gives me a slightly confusing looking error. So don't worry about what this stuff means. What it's simply telling you is that f of 1 did not turn a value, so you cannot add nothing to 1.